Finally managed to complete my flow, and now we can talk about Postgres in NodeRED. Hey guys, today we are going to talk about Postgres in NodeRED because that's what I've been doing for the last couple of weeks, trying to learn it, how to use it, and develop a nifty tool that I can use now to benchmark my Raspberry Pis. Now, if you want to jump straight into the tutorial, which is for beginners, including installation and everything, then I'm going to leave the timestamps in here on screen so you could jump to relevant sections so you can get started straight away. However, I would strongly recommend you just stick around and learn why I've selected Postgres and what are the advantages of running that as a database over something like InfluxDB. I already have a database, InfluxDB, and I use Grafana to plot beautiful charts, so why do I need another database? And it's actually a good question because it's going to be down to how you would like to store your data and retrieve it. Now in this video I've covered all the details about how to get started with Grafana and InfluxDB, which is brilliant for storing data from something like sensors. InfluxDB is a time-based database, which means every entry is going to be correlating most likely to a timestamp. Now Postgres, on the other hand, is an SQL-based database, and they store the data in a slightly different way. So what happened? What are the limitations of time-based databases that, well, SQL databases don't have? Well, a couple of weeks ago I started to work on a custom tool for benchmarking Raspberry Pi enclosures. I wanted to display charts and overlay the charts from individual tests together to give me a better understanding of which case has the best thermal performance. And up until now I was doing this with a InfluxDB and time-based entries. So every time I've completed the benchmarks, I could open a Grafana and I could see the actual graph of the benchmark. However, there was no easy to stack that data one on top of each other because, well, different benchmarks were taken on the different days and it's not ideal. And yes, with enough time and patience, you probably could find a way to recalculate everything and figure out how to add certain amount of seconds to the current benchmark, and well, it's complicated and you probably don't want to approach this problem this way because there is another solution. Unlike time-based databases, SQL doesn't really rely on time. So if you're not looking to store the sensor data, but for example you want to know how many apples Adam has and how much money he spent on all of those apples, then something like SQL is better suited. I started to look through different SQL databases and Postgres stood out to me for a couple of reasons. First, I wanted a nice and easy integration with Grafana. Unfortunately, that bit backfired on me slightly, but I'm gonna explain that in a second. My second reasoning was that I could actually store arrays. Something like SQLite doesn't have the ability to store that data type, however Postgres allows you to store arrays. And I envisioned that I would store the time of consecutive seconds, so like 0, 1, 2, 3, etc. of each test in an array, and then I would load that to a chart, and that way I could load multiple charts overlaying each other. I actually hope that because Grafana has a free tier integration with Postgres, that would let me select that array of seconds and plot that or use that for the x-axis to plot my chart. However, Grafana didn't want to see that as a timeline and just rejected the input. I think that has something to do with the fact that Postgres actually has a data type of timestamp and Grafana was looking for that instead. But anyway, I still ended up using Postgres and that's why we have this video. Don't get me wrong, you can still visualize a lot of different data using Grafana and Postgres, but for that particular case I had to find a new solution. And I discovered, well, I didn't discover anything new, I just referred back to the original charts from dashboards in NodeRED because, oh, this thing can plot anything, even if the data doesn't have sense. Just like on this graph where I'm actually using random strings to pretend that they are on the x-axis. It doesn't make sense yet, but I figured out where the problem was. There is one more thing that I would like to address before you throw this in my face. Why am I using the database to begin with? It is true. For this project alone, I could ditch the database and I could just use NodeRED and the fact that I can store data in a persistent context, but it's not really scalable. I know this benchmark tool doesn't really require that massive scale, and realistically speaking I'll end up with 50 to 100 entries in total, but I wanted to learn something new, and let's face it, without me experimenting with databases you wouldn't have this tutorial to begin with, so I think that's as good reason as any. Another advantage of this setup is that I'm actually hosting the database on another computer, so I'm also communicating over the internet, and I'll teach you this in that video. Okay, I think I've said enough, so it's time to start the tutorial. And just to let you know, in the description of this video you're going to find an article with all the commands and detailed instructions, so if you want to grab something from this video instead of looking at the screen and typing, just go open the article, read it at your own pace and grab the commands by simply copy and pasting them. So the first step is obviously to update your system so you could actually find PostgreSQL. I know it's PostgreSQL, but that's what I'm going to call it. So once you have it, just use the typical install command, and then PostgreSQL is what you need to install. I have it already installed, so obviously that didn't install for me. It will take a couple of moments and you'll have it there. Now, by default, you can start PostgreSQL or Postgres with PSQL. Now, that won't work for you because you are using Pi as your user, and you won't have that user until you create it, so we'll have to change the user first, and you can do that by sudo su, and the default username for Postgres is, yes, you guessed it, Postgres. And now with that we have a correct user, we can actually use Postgres, so PSQL, there you have it, you are here. Now I've created some database in the past in there, so they are existing in a system, so if you do the / and then L, it'll list your databases. You'll see that I have a couple of in here, but you probably need to create one, so let's start with that. I'm gonna type my commands with the uppercase, create database is the command, and then just followed by the name of the database. Let's say, I don't know, tutorial, and then followed by semicolon. That's how you create a database. You can see the database has been created, and now you have a database which is also linked to your user. That's important because later on I'll show you a trick. Now let's create, while we're here, let's create a new user, and that is also easy. So what you need is just the commands to create your user, and then type in your username. I'm going to use Pi. I think I might have it already, but I'll show you what I mean. And then you have to type in your password in the single quotation marks. So let's say 1, 2, 3, 4, 5, 6, that's fine. And you can either create a user without a password, so you won't need this. You can use user with a password, so you don't need the word encrypted. Or why wouldn't you like to encrypt your password? I don't know. Now another thing that you can do, and I would strongly recommend it you to do, is to create a user that can create a database, and you can achieve that by adding extra command. Oops, let's do it. And that is create database. So I already have a Pi. Now remember earlier on when I was trying to log in, let's exit out. Remember when I was trying to log in, you can see that I already have a user Pi, but I told you that I could not log in. I can try that again. PSQL, see, it doesn't have a database associated with it. However, there is a trick to that. You can specify the username and the database as you open Postgres. And you do that in the following way. So obviously in here, username is going to be Pi, and the database, what we've created, what was it? I think tutorial. There you have it. And I'm already in the database, logged in as Pi, not as Postgres, but as Pi. So that's how you can do it from a single line. Once you are in a database, there's a couple of things that you can do. I already mentioned that you can look up your databases with \L, and that will list your databases. But that's not the only way to do it. We can look up tables. If you want to open the table, you just type table and whatever table is inside. I don't have any created just yet, so that's not going to work for me. If you want to verify what tables do you have, you'll see that you have to be lowercase letter I said. I do not have any tables in a tutorial database. These are basically the basic interactions that you can use. If you, for example, want to see all the users that you have, you can get your users using this command, select all from PG users, so it's the list of all users, and you'll see all the details about your users. I probably should show you how to reset the password. So you can do password and then your username. So let's change the password, but you see, I'm gonna change to the same 1, 2, 3, 4, 5, 6. Nah, that's how you change the password. Okay, that is pretty much it in terms of basic operation. You probably don't want to interact with your Postgres through SSH or through terminal. You want to do it in NodeRED, and we're going to jump into that in a second. But before we do that, I also want to show you how to access your database from afar. By default, you can only access it from the same machine, but sometimes that might not be perfect and you want to access it from another computer, and you have to enable that. So the first thing that you have to do is to go to this location. But one of the things you have to pay attention to is the version of the Postgres you've got. So for example, I know this is my location, right? And I know that will open. But let's go, actually go step by step, and I'll show you what is important in here. So if I was browsing my directory, you'll see that in this directory can have a version. Your version might be different if you're watching this later. You might have 14 or 15 or whatever, but if that's the case, everything else will change. So I'll be in the main, and then first file we want to edit is pg_hb_a_config, and I need to actually use proper commands. So sudo nano. That's the config file that we want to edit. You will see that we have connections available in here, and by default on IPv4 we have just localhost. This means that machines from localhost will be able to access this. Now to make a new entry for each, you'll have to add something. So for example, I have a range in here, which basically I'm allowing all hosts. The last bit in here is basically you trim how much of the IP filter you want to use. So if you use 32, you only be able to access it from that IP. If you use 16, you will be able to access anything on 10.0. If you use 8, you'll be able to access on anything that starts with 10.0. So you can decide what is the IP filter in here, or subnet mask, this way. So that's the first change. I'm going to leave it with a 16 because that is a good number. I'll be able to, well, yeah, that's fine. And then I'm going to save it. Now the second file that we want to modify is this one, Postgres config file. In connections and authentication, just look to the listed address. And in here, obviously, localhost is, you're going to listen to localhost. But if you want to have ability to listen on all ports, you would do something like, you would do something like that. That would accept basically requests from everything. Now, if you want to get any values from a specific IP address, for example, let's say I want from my computer, then I would set a single IP. If I want to have multiple devices, then I will type another IP. For example, like this, and I'll have two IPs that I'm going to listen to on the port 5432. That's the default port. So this is how you specify that and open your configuration to network interactions. So to get started, you have to go to your Manage palette and then install and look for PostgreSQL. So PostgreSQL. That's the one you have to install, and you'll see those blue nodes with an elephant on it. Before we go any further, I have one warning. If you're going to export and share your projects, including Postgres node, that will expose your password to your database in a plain text in a JSON file. So either before exporting it, change the password to your database on something generic, so you could stay safe, or just go to the JSON file itself and edit it out to keep your database secure. When you open your node, you also have to configure your server. Now in this case, I'm running NodeRED and Postgres on the same instance, so it's just accessing it via localhost. Now the port I left it by default, and I'm using a database which is in this case called thermal test. Now I've set up security credentials in here, and that's pretty much all I've done. If you're using a remote database, you'll have to forward that over and follow the configuration for remote access I've spoken about earlier. Alright, by default there are two ways of interacting with a node for Postgres. First is the manual way, and the second is a programmatical way or dynamic way. So manual way means that you're going to send your query from this window. You're going to type the type of the query you want to do, all the parameters, all the data, and you're going to submit it. When you do that, all that information that you've typed in is submitted as once. So let's take a look. It's probably not going to let me submit this because I already have that database. So let's remove it and let's do it again. So I've created my query and I'm now submitting it to a server. The fact that I've got empty response in here like that means everything went okay and there were no errors. That's important because if you have any errors, none of the data is going to end up in your database. I will assume that you've created your database using SSH, and in here in NodeRED you just want to create your first table. Table is where you store your information, and I'm going to show you how my table is created in here and what's what. Now obviously the command is create table. It doesn't have to be caps, but I've used caps to kind of indicate where's the command and where's the parameter. So create a table, and the name for my table, in this case the name for the table, not for the database, is thermal test. And then in my brackets you will see that I have in here my parameters that I'm going to include. So each parameter in here is going to be a column in that table. So the table should have a primary key. Primary key is how the device recognizes, or how the database recognizes new entry. And there are a couple of ways you can do it. Now at first I had my primary key to set as serial. What serial means that it is a unique number that's going to be iterative. Every time I'm making a query or adding new data, that ID, I've called it ID, it's going to be iterating. So if I'm writing a first thing in there, it's going to say it's ID 1 or 0. Second one, it's going to say it's ID 1. Third, right to the third row, it's going to have ID 3. And you need a primary key that is unique because that's how databases recognize new entries. So later on I discovered that I didn't really needed to use a serial for my scenario because I wanted to be able to trace back that serial, so I needed to assign it before I'm sending it to the database. I had my reasons, but that's not necessary. Another advantage of the ID being serial is that you don't have to submit that for the new entry. The database automatically will populate your ID and assign it. Obviously you have to submit that as your table configuration, but later on when you submit in data you won't. I'll explain that. So every single column will have a column name, in this case it's ID, the data type you're going to submit, so this is a big integer, this is a varchar, which is basically a string, numeric is a number, and in this case I have an array of it. There's an int, integer, and then also have a number of it. There's a date as a type, boolean, numeric as a symbol, and there's a lot of different data types that you can actually send to Postgres. So I would refer you to documentation to get the full scope of different data types that you can send. So I've got my table now, and I've submitted that data manually. I didn't really need it to do anything programmatically in here because you only do it once and then really you don't have to do it again. Now the second one is to remove the table, and that comes with a warning because it's far too easy to remove the table and lose all the data. All I had to do to remove my table and lose everything that is written into it is just drop the table. That's it. I no longer have any of data that was assigned to that table. So be careful because there are no confirmation. And the command for this is just drop table and the name of the table followed by a semicolon. That semicolon is going to be for each query, so do remember about that. Okay, so let's create my table again. So I have a place to write it into, and let's send some data. Now in here you'll see that I have a insert into command, and I'm inserting into my table, which is called thermal test, and then I have selection of different columns that I'm going to populate. You don't have to populate every single column, but you'll have to populate all the columns that are having the parameter not null. So this is the parameter restriction for each column. So in this case I've decided that I will only accept the entries that have device and test type. If I was missing device or test type and my values would be set to null, they would not succeed and the write to the database would be unsuccessful. So in here you'll see that I've specified all my different columns that I want to populate, and for my ID I'm using 1233. For my name I'm using device, I'm using my device string, word of advice, make sure it's a single quote, not double quotes, otherwise it won't work. If I want to submit an array, this is how you format the array to submit it. If you want to submit the date, this is how you submit the date. It has to conform to our ISO standard and booleans and so on, so on. So our entire query ends with semicolon, and now when I'm trying to submit that data, you'll see that this entire row is going to be submitted in here, and I have it in my table. So now this is part of my table and I've submitted it. Now remember when I've created the table I told you that if you have a serial, word serial in here, then you don't really have to submit ID for the new entries. If you're doing insert like I did in here, you'll see I've added my ID, but if I had my ID set to serial, I could just drop it because I knew with the new insert action I would have a serial ID added to that row and I could query it later to find out what was my ID. Okay, but submitting data into the database manually is kind of boring and not really how we're going to do things. So let's do it dynamically. To submit that programmatically, what you have to do, you have to create an object called message params, and that is an array. You can see this is an array that will contain elements. In this instance I have a first element, it's ID, second temperature, third timing, then device and test type. Now because I have to submit my ID manually, I cannot generate it because that's how I set my table. I have to make sure that ID is always present because this is how I'm going to refer to my rows. So in here I've assigned it some values. So for my second write I have a new ID. I've assigned the temperature to be this array, I assigned timing to be this array, and some other names. Those two, device and device types, they were mandatory fields, so I need to make sure they're not null. And then I compose that message parameters with these variables as an array, and then I just return the message. Now to pass this over in a query, I have to use the command, so insert into, then I'm inserting into thermal test, and all the parameters that I have here, you can just simply copy. So select all of those, copy them here, and then for each value, so the corresponding values, I'm gonna have my first, my second element, third element, fourth, fifth, and so on. So my first element was ID, my second element was temperature, my third was timing, and so on. And the order that it's going to take in consideration is the order from here. So bear that in mind. That was my first element, that's my second, that's my third. Okay, so now you know how to set that row dynamically, so let's do that. Great, no problems there. Now another thing is update row manually. difference between the update and set is that update allows you to either replace or add value to specific columns in an existing row. Obviously, to do that, you'll need to know the row ID. So in this case, remember my first insert had ID 1233, and that's why I'm going to do it here. I'm going to update my table, which is thermal test, and in here I'm setting temperature column, and I'm using a command array append, and then I'm appending temperature and the value of the temperature. And the same in here, because I'm using arrays, I have to use that function array append, introduce what I'm actually appending and the value. Now there is a catch which I wasn't able to figure out. These things will return an error. So if I try to run this, you'll see that I have array append numeric integer does not exist. This is because in my table I've created a temperature, a numeric array, but what I'm essentially sending from this is a int, and this is what it says, that the integer isn't compatible with my numeric array. And this is a limitation that I've discovered and I don't know how to bypass. Now, if I had an array of ints instead of array of numerics, that would work just fine because that number is being treated as an integer. So if you're just assigning something like, I don't know, let's change the device name, then I would simply do something like that, new name, and I'll be quite happy to have it. Each line should have a comma at the end of it, and that will work as well. I'll have no problem with that, but because of this, it stops actually updates, and I wanted to show you that you have to match the data type for each update or insert, otherwise the entire writing to database will fail. So since I don't know how to bypass it, I'll show you how to make it work. Because it's very unlikely that we're going to be updating rows manually, and if you use the function node, the problem is kind of solved by itself. You'll notice in here that I'm going to do exactly the same. I'm going to pick my row 1233 with ID, and I'm going to use integer 21 and integer 6, and I'm going to assign those to the existing row, or append it to the existing record. So I'm setting my message parameters to have ID, temperature and timing as a third element. So if I go to my update table node, you'll see that I have again update command to a thermal test, and then I'm setting temperature, array append temperature, and this time instead of value I'm using the number of element, the element in my array. So my ID was the first, my temperature was the second, and timing was the third. And let's see if that works. As you can see, this worked fine, and I actually updated the record in here, which means between here and here the node took the integer and converted it automatically into the numeric. So you could update the table of numerics that I've set in my create table node. So this is how you bypass it, and like I said, update row manually, you're not going to do it that much often, so I stopped after one page of Google results and I gave up looking for a solution to that. Okay, so you know how to write and update the record. You probably want to recover some of that data and see what's what, right? So let's do our first read. To read the information, you have to select a record from table. In this case, I'm just using a star because it means select everything, and that'll give me a record of what we have written so far. So let's try this. So as you can see, I have two rows as a result. So one row, which is with ID 1235, and then one row with ID 1233. So if you take a look also, you'll see that my update, when I was appending the temperature and timing in here to one of the records, it shows that I have 5 different elements in here. So when I was actually setting the data and updating and adding extra information, so let's see, I should have another 21 and another 6 added when I run this command. So let's do that. I've added extra data, and let's read it again, and my record should have 6 elements right now. You can see them here. So everything is working as intended. So that's how you read that information. However, it's important that you try and not to read all the information from entire table, but grab the information that you need. There is a balance that you have to strike between having everything read on a single query and using multiple queries to draw the data from the database. Since I know I'm not going to need all of that, let's try to figure out how to read just some of that information. So let's start with this. Let's select a specific ID and device only. So all the records that I have, all the rows, and currently I have 2 rows, I'm only interested in the ID and I'm only interested in the device name. So that's how you would do it. Let's run this and see what we're gonna get. Now we have 2 results because I have 2 rows. And this time, instead of having all of the columns that I had before, I only have an ID and I only have the name, because that's what I've asked. Another thing that you can do, you can specify what you want to get in what order. So in this case, I am selecting from my database these columns, so ID, device, test type, fan, average, and that's from my thermal test, but I want my results to be ordered by average temperature, limit 10, so I would only want to display 10. Now this will fail because if you remember when I was reading all the information before, I didn't have the average information set in here anywhere. What I have a temperature, timing, but I don't have an average set, so this query would fail. But if I pick another thing that is actually populated, I would be able to query that information and only get, in this case, 10 results based on average temperature from my data. And just as before, you can read information programmatically in the same way. So let's say I wanted to read a row which is 1233 only. So I'm going to assign that to message parameters as an array and submit that to my read data, where the ID is substituted as a variable. So again, I'm selecting entire record from the database where the ID or the raw ID is my variable. If we're going to run this, I'm going to get one result. Let me deploy this. I'm going to get one result matching that ID. Here you go, that's it. And lastly, I'm going to delete the row. And just like with dropping entire table, be careful, because if you're not being careful, you can delete more the information that you want. Delete from table, where will specify what kind of information you want to delete. I've specified the ID because I want to delete a single row. But if you, for example, specify device and then submit the device name, it would delete every single row where the device name is whatever you specify. So if you have 30 different entries for the same device name, it will delete 30 different rows for you. So we have 1233 ID in here, so let's set that 1233 and let's delete that row. So the row is now deleted, and if I'm going to read all the data, you'll see that I only have one row, which is 1235. Okay, that should get you started with Postgres in NodeRED. Now do yourself a favor and spend some time actually reading about different data types and different ways of processing your queries, so you'll figure out what is the best and efficient way to retrieve all the data you need in appropriate order. It will save you some time and precious database calls, so you'll thank me for that later. As for now, that's pretty much it. If you want to download the sample flow that we were working with, in the description of this video you're gonna find a file to that alongside all the commands and everything we've been talking about in this video. So big thanks for watching. Let me know in the comments what you're going to use the database for, and if you know any cool tricks with Postgres, to let me know that as well, because hey, I'm just like you, I'm still learning. So thanks so much for watching, guys, and you know how YouTube works. I do not have a posting schedule. Use the tools provided to find me and my next video. Take care. Bye.